What's up guys, in this video I'm just gonna talk about some issues related to the pharmaceutical calculations. In fact, I just want to do a little review on ratio and proportions. Well, ratio and proportions, these are the very basic thing of pharmaceutical calculations, and in many cases we need to calculate a lot of things using this ratio and proportions. Well, so there are two things. One is ratio and the second one is proportion. So what is ratio and what is proportion? Ratio means the relative magnitude of two things. Say for example, something is written like a solution. Say for example, a solution of 250 ml contains 20 milligram of drugs. This is just an example. 250 ml of a solution contains 20 milligram. So now this is just an statement, and if you want to make a ratio from this statement, it might be like 250 to 20, or you can write it like 250 by 20, or you can do the reverse like 20 by 250 or 20 is to 250. So this way you are just actually representing the amounts, and the way of representation is called ratio. So now the thing is that what is proportion? So proportion means you are just actually there are two ratios and you are just making a mathematical relationships with these two ratio, and in that case this relationship is equality. So for example, if I just give you an example like say 100 ml solution contains 10 gram of drug, certain drug, and another case like 200 ml of solution contain 20 gram. These are two different statements. Now if we talk about the first line, it comes like 100 by 10, and from the second line it comes 200 by 20. And if we just want to say that these two ratio are equal, we have to put an equal sign here, and when we put an equal sign between two ratios, it becomes a proportion. So this proportion, basically we construct proportional relationships from different ratios, and we use these different proportional equation to solve different kind of pharmaceutical math. Like say for example, I just want to give you another example of proportion. So I'm just doing this review from the book of Leon Scherzel. Basically this is a book for Naplex, and so far I remember it is commonly known as CPR, Comprehensive Pharmacy Review for Naplex by Leon Scherzel. This is the book, and the chapter is Pharmaceutical Calculations. Okay, so let's get back to the ratio or proportion. So here is an example. It says if 240 ml of a cough syrup contain 480 milligram of dextromethorphan, then what mass of drug is contained in a child dose, that is 5 ml. So the question is given 240 ml of a cough syrup. I'm writing in short form. 240 ml of cough syrup contains 480 milligram of dextromethorphan. Now the question is asking what mass of drug is contained in child dose. Mass in child dose, and it is also mentioning that child dose means 5 ml. Now you see you have two informations, 240 ml versus 480. This is statement 1. This is just giving you a ratio, and the second one is 5 ml versus x milligram. Here 240 ml is related with 480 milligram, and here 5 ml is related to x milligram. So we can make a ratio like 240 divided by 480. This is kind of a ratio, and we can make like something like this, 240. So it is it is to be written by 5 by x. So this is how you can make a relationship with some unknown numbers, and you can solve it. Like if we can calculate x from here, it will be like 5 into 480 divided by 240, 0 0 2. So x equals 10. So x equals 10. Yeah, x is 10 milligram. Now I just want to give you some very clear concept. Like here we have written a mathematical equations having two ratios on the both side of a equation. I mean both side of a equal sign. So this is a ratio, this is another ratio, and we are making a mathematical relationship, and this relationship is called the proportion. So from this proportion we actually make what we make a mathematical relations, and we solve different kind of mathematical problems. Now one thing I need to tell clearly, like 240 480. So 240 is in ml and 480 is in milligram, and the same way 5 is ml and x is milligram. So milligram versus ml versus milligram and ml versus milligram. So there are two different kinds of thing, like one is mass and another is volume. So two different kind of things are being putting into a relationships, mathematical relationship with two ratios. So this is called, these two things are actually called mixed ratios. We are mixing two things, like one is volume and another is weight or mass. So this is kind of mixed ratio, but we can also do the same thing by using proper ratio. So what is proper ratio? So proper ratio means on these calculations you are obviously making a relationship, but this relation is to be in proper way. Like we have to write this way. I'm just shorting it down. 240 versus 5 equals 480 versus x. The same way, 240 ml versus 5 ml equals 480 ml versus 480 milligram versus x milligram. This is basically the same equation, just the position of the volume has been changed. Like 5 ml was here and 480 was here. Now it has been just shifted diagonally. So that can be done in mathematics. But the thing is that the way you are representing now, it's a proper ratio, because you are relating two similar things like volume versus volume and the weight versus weight. So the way you are representing the way you are representing two ratio is called here the proper ratio, and the way you are representing these two ratio, this is called mixed ratio. So whatever, either it is a proper ratio or it is a mixed ratio, you can use this ratio setup to make the proportional connection between different things and can solve mathematical problems this way. Now another thing I just want to solve for you, like inverse proportion. It's a very interesting thing. So let's clear my board first. This is one of the very important thing. Like most of the people used to do a lot of mistakes while it comes to the inverse proportion. Generally different kinds of problem you can solve by using the mixed ratio or the proper ratio, but while it comes to certain mathematical problem, it becomes an error because you are not using the formula properly. So these are the case while we think about the inverse. Let me change my pen. Do I have any extra pen here? Yeah, I do have one. Yeah, it's a new one. Inverse proportion. So this is a proportion which is inversely relating two ratios. So what I'm telling, a proportion that relates two ratios inversely. So obviously proportion means that must be two ratios, and these two ratios are related with each other inversely. That is the basic funda of inverse proportion. Now how you gonna use it in mathematical, pharmaceutical math specifically, not for other issues. We are just talking about pharmaceuticals. So let's have a mathematics here. If 120 ml of a stock solution is diluted to how much? 240 ml. You just think about 120 ml of something is there, and now you are diluting it to 240 ml. Very simple thing. So what will be the final concentration? What will be the final concentration? Now it is also given the stock solution is 10%. So now just have a look. We have a couple of informations given here, like there is a stock solution. This is kind of a previously prepared solution. You can call it a standard stock solution. This is 10%. It is already given 10% stock solution. The total volume is here, it is having 120. Now you are diluting, like making the volume double. Like now the volume is how much? 240 ml. And the question is, what is the concentration here? So the thing is that you are just expanding the volume, so obviously the concentration will go down. This is not like that. If 120 ml solution is having concentration 10%, so the 240 ml of solution will have almost, so here is a relation of double. 120 into 2 equals 240. So 120 ml solution is having a concentration of 10%. Doesn't mean that 240 ml of solution will have a concentration of 20%. This happens if you just put the relationship in a wrong way. I'm just showing you first the wrong way, then obviously the right way. So the wrong way is 120 ml 10% equals 240 ml X%. So this is a ratio, and you are relating these two ratios, but not inversely. That's why you're going to have a very big problem here. So X equals what? 240 divided by 120 into 10%. 20%. This is totally wrong, because you diluted the solution. It does not mean that you will have a double concentration. It will actually become half. So we made a relationship, but that relationship is not proper. It is to be inversely proportionate, because once you dilute something, the volume will expand, at the same time the concentration will fall. So the relation is to be reverse, inversely. So how you have to write it down? Like, you have two informations here: 120 ml, the initial volume, and the second volume is 240, and you know the concentration of the first solution, that is 10%. You have to put the 10% here, and unknown percentage here. Or you can do this, do the things in a different way, like 120. You are making these solutions using mixed ratio. Now if you use it with proper ratio, it will like 120 versus 240. So the relationship will be inverse. So what does that mean? It means, so 120, it will be like x% by 10%. See, for example, 120 ml was having 10%, but you are now putting that things in an inverse way. That is the basic funda of inverse proportion. So if we solve that way, whatever the equations, either the equations using the proper ratio or the mixed ratio, we have to put these things inversely. I mean, the concentration and the volume is to be related inversely. So now if we calculate x from here, either from this one or that one, basically both are same. If you just change the position, a proper ratio will be a mixed ratio equation, or a mixed ratio equation will become a proper ratio equation. So whatever, if we calculate x from here, it becomes like 120 into 10 divided by 240. So it comes like 5. So x equals 5%. So just I can recheck. When it was 120 ml, the concentration was 10%. Now it is 240 ml, I mean diluted. So the concentration went to 5%. Now this is perfect. I mean, now it actually giving you the right result, correct result. But if you do not know that the things are being related either proportionally or inversely proportionally, then it's gonna make a problem for you. I mean, it will make you to go into a wrong answer. So I think this is quite good enough for today. Maybe in the next video, hopefully I will discuss something like formula for the parts, and also do something like dose calculation and a lot of things. I need to I need to prepare myself. So the purpose is to make the review what I have learned from there. So good luck. Hope to see you in another video.